the organic compound reacts with sulfuric acid and first what did it form? Ammonium sulfate. Quantitative analysis of nitrogen can be done with two methods. One is Dumas method and the next one is Geldahl's method. Pressure of the gas is considered as P and the aqueous tension is considered as F. The organic compound decomposes to give nitrogen gas along with carbon dioxide. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So in the last session, we studied about the qualitative analysis of organic compounds, right? In an organic compound, how we can detect the presence of various elements. And then we begin with the quantitative analysis also. So in the last session, we discussed and studied about the quantitative analysis of carbon and hydrogen, that is Liebig's method. So in today's session, we will be studying about the quantitative analysis in further, that is estimation of nitrogen and then estimation of halogen, sulfur and phosphorus. Right. So let's begin with the first one, that is estimation of nitrogen. So the quantitative analysis of nitrogen can be done with two methods. One is Dumas method and the next one is Geldahl's method. So first we'll begin with the first one, that is Dumas method. So what is the principle behind this and how is the procedure, we'll see. Okay. So first let's begin with the principle. In this method, the given organic compound is heated with copper oxide. So our organic compound is heated with copper oxide. So what happens? In the presence of carbon dioxide atmosphere. Okay. So our organic compound is heated in the presence of copper oxide in the presence of a carbon dioxide atmosphere. So what will happen? Nitrogen gas and oxides of nitrogen gas are formed. Okay. So if the organic compound is containing carbon, that will be converted to carbon dioxide. Hydrogen will be converted to water. And nitrogen will be converted to nitrogen oxides, and then the nitrogen oxides will be further converted into nitrogen gas. So in this method, you will be getting three gases, that is hydrogen if it is present, water, yes, and then carbon to carbon dioxide, nitrogen to nitrogen gas, right? The oxides of nitrogen gases are converted to nitrogen by passing over heated copper gas. Okay. Now, the gases formed are collected over potassium hydroxide solution, and from the volume of nitrogen gases obtained, the percentage of nitrogen in the given organic compound can be determined. So, this is the apparatus that you can see. So, before discussing the apparatus, let us see the procedure, right? So, as said, a known mass of this compound, organic compound, which is containing the nitrogen is taken and it is heated in the combustion tube containing copper oxide. Okay, it is reacted with in a combustion tube containing copper oxide and in the presence of a carbon dioxide atmosphere. That means carbon dioxide is passed through the tube. Okay, so as you can see, this is the combustion tube and carbon dioxide is passed through it. Right, and you can see this will react with, this is copper oxide gas is there, copper oxide plus organic compound, coarse copper oxide and reduced copper gas. So what happens is we take the organic compound, yes, and we react it with copper oxide and we pass carbon dioxide through it. Okay, so this is the first step that happens. Then what happens? The organic compound decomposes to give nitrogen gas along with carbon dioxide. Okay, so nitrogen, when it passes through this combustion tube which is containing the copper gas and everything, what happens? Yes, copper oxide gas, what happens is it gets converted to carbon dioxide, that is carbon gets converted into carbon dioxide and nitrogen gets converted into nitrogen gas, right? And water, hydrogen gets converted into water and traces of oxides of nitrogen will be also found. The oxides of nitrogen are converted to nitrogen by passing the gases over heated copper gas. Okay, so overall what happens is when we are reacting the organic compound with copper oxide, yes, and it is carbon dioxide is also passed through the tube, then what happens is carbon gets converted into carbon dioxide, hydrogen gets converted into water and nitrogen gets converted into nitrogen gas and some nitrogen oxides will be also produced. And what to do to convert this nitrogen oxides into nitrogen? Yes, it will be passed over copper oxide gas, and you will get the nitrogen. So as you can see here, this is the organic compound taken here, and it is made to react with copper oxide. Yes, the nitrogen gas will be produced from the nitrogen, carbon dioxide from the carbon, and water is also produced, right? And the extra nitrogen oxides which is present, that is oxides of nitrogen, it is made to react with copper gas as well, and then you will get the nitrogen gas. So this is the procedure, right? And the nitrogen gas, where in this apparatus you will be able to obtain? Yes, as you can see here, till here, the blue color part you can see, that is potassium hydroxide solution. The blue color part you can see is potassium hydroxide solution, and above that the nitrogen gas will be accumulated. So above the potassium hydroxide solution in this tube, above the potassium hydroxide solution, you will find the nitrogen gas. Nitrogen gas will be obtained there. And what is the significance of the KOH solution taken here? The carbon dioxide which is coming out of this combustion tube, that will be absorbed in the potassium hydroxide solution. So carbon dioxide gas will be absorbed here, and the nitrogen gas will be present on top of it, right? Yes, okay. So now the gaseous mixture is collected over aqueous potassium hydroxide solution. Carbon dioxide is absorbed by KOH, and nitrogen gas is collected in the gas jar. On the top you can see nitrogen gas. From the volume of the nitrogen gas obtained, we can calculate the percentage of nitrogen which is present in the organic compound. So once you obtain the nitrogen over the potassium hydroxide solution, from the mass of the amount of nitrogen gas which is obtained, we can calculate the percentage of nitrogen. So now let's see the calculations, how we can calculate the percentage of nitrogen, because we are doing quantitative analysis, right? We need how much percentage of nitrogen is present in the whole of the organic compound, right? So if you are considering the mass of the organic compound as m gram, right, and the volume of nitrogen gas formed is taken as V1 ml. Okay, nitrogen gas which is formed in the product, finally how much it is formed, we are taking it as V1 ml. And room temperature is also needed to be noted here. Room temperature is T1 Kelvin, right? And the next one is pressure of the gas is considered as P, and the aqueous tension is considered as F. Now what is the importance of aqueous tension here? As in the apparatus you saw, above the potassium hydroxide solution, nitrogen gas will be accumulated. So as it is over the potassium hydroxide solution, it will also contain some liquid presence, like some water will be also present with the nitrogen gas. Okay, it won't be completely dry. Hence, the aqueous tension also needs to be considered, right? So now continuing with the part, aqueous tension is the pressure exerted by water vapor in the gas collected. So as you can see in this apparatus, yes, nitrogen will be collected here, and there will be presence of some water as well. So it is the pressure exerted by the water on the gas, right? So that is aqueous tension. So we have to consider that as well, right? So then what will be the pressure of the dry nitrogen gas then? Yes, it will be the atmospheric pressure minus aqueous tension, right? So the pressure that we have to consider in the calculation is the atmospheric pressure minus the aqueous tension, right? Okay. Now the volume of nitrogen gas at STP will be P minus F, that is the atmospheric pressure minus aqueous tension, into V1 by T1 into 273 by 760. So 273 is the standard conditions temperature, and 760 is the standard pressure, right? So this is how you calculate. This is from the simple equation P1 V1 by T1 is equal to P2 V2 by T2. So P2 V2 by T2. So if you have to calculate V2, what you will do? P1 V1 by T1 into T2 comes here. So that is how you have obtained this particular equation. And 22,400 ml of nitrogen gas at STP contains 22 gram of nitrogen gas. So that means this is what? This is molar volume, right? Under STP conditions, 20 gram of nitrogen gas will contain 22,400 ml of nitrogen gas, right? Okay. And then V ml of nitrogen gas at STP will contain 28 into V1 by 22,400. Okay, so if 22,400 ml is containing 28 gram, then V will contain 28 into V1 by 22,400, right? Okay. Now, finally, how we'll calculate the percentage of nitrogen? It is 28 by 22,400, which is the molar volume, into volume of nitrogen gas at STP. That volume of nitrogen gases STP is calculated from this particular equation. Okay, this volume of N2 at STP is calculated from this equation, divided by mass of organic compound into 100. So, this is the final equation from which you can calculate the percentage of nitrogen, right? So, this was the first method to determine the percentage of nitrogen, that is do-mass method. Now, let's do a numerical based on it. In do-mass method, 0.30 gram of an organic compound gave 32 ml of nitrogen gas at 27 degrees Celsius and 750 mm mercury pressure. Calculate the percentage of nitrogen, and aqueous tension at 27 degrees Celsius is 20 mm. So, pressure is also given, aqueous tension is also given, the temperature, masses and everything is given. So, let's write one by one. The mass of organic compound is given as 0.30 gram. It is given, right? And the volume of nitrogen gas formed is given as 32 ml. Aqueous tension is given as 22 mm of Hg, and temperature is given as 27 degrees Celsius. You have to convert it into Kelvin scale, right? So, how do you convert it? Degrees Celsius plus 273 will give you, yes, the temperature in Kelvin scale, right? So, that is 300 Kelvin, and the pressure of the gas collected is also given as 750 mm Hg. The pressure is also given, right? And the aqueous tension is also given. So, now how to do the calculation? Volume of nitrogen gas at STP is given by 750 minus 20. What is 750 minus 20? It is the difference between atmospheric pressure and aqueous tension, which will give the pressure of the dry gas, right? Into 32, which is the volume, divided by 300. 300 is the temperature which is given, which we converted into Kelvin scale, right? And into 273 by 760. This is in standard condition, and you get the value as 27.97 ml. So, that is the volume of nitrogen gas at STP. Now, how do we calculate the mass of nitrogen gas in the given compound? It is 28 into V by 22,400. So, this V we calculated from here. Yes, that is 28 into 27.97 divided by 22,400. So, that will give the value 0.0349. Okay. So, once this is obtained, we can calculate the percentage of nitrogen. It is calculated by 28 by 22,400. So, once this is done, we can directly calculate the percentage of nitrogen. Yes, 28 by 22,400. Already there. Volume of nitrogen gas at STP. This is what we have calculated now. And the mass of organic compound is this one, right? And finally, if we substitute all of this, we get the answer as 11.63%. So, this 100 also is necessary here. So, that is equal to 11.63. So, I hope the calculation is clear. Now, moving on to the next method, that is called as the Gel-Dals method. So, as I said, there are two methods by which we can calculate the percentage of nitrogen. The first one is discussed already, that is do-mass method. The next one is Gel-Dals method. So, the organic compound is strongly heated with concentrated sulfuric acid. It is heated with concentrated sulfuric acid, and the nitrogen is then converted into ammonium sulfate. Okay. So, the organic compound which is containing nitrogen is heated with concentrated sulfuric acid. So, what happens to the nitrogen? Nitrogen is getting converted into ammonium sulfate first. Okay. Now, this solution is then heated. Whichever ammonium sulfate, the solution containing ammonium sulfate is then heated with excess of sodium hydroxide solution. Ammonium sulfate now reacts with sodium hydroxide, and then what is liberated? Ammonia is liberated, and ammonia liberated, which is absorbed in a known excess volume of a standard acid. Okay, so ammonium sulfate reacts with sodium hydroxide in excess, and we get ammonia gas. Ammonia gas is liberated, and this is now absorbed in a excess volume of a standard acid. Why standard acid? Standard means the molarity will be known. So, I know the concentration of this acid, right? And the volume of the unused acid is determined by titrating the solution against a standard alkali. Now, this gives the amount of ammonia absorbed, and from this the percentage of nitrogen is in the compound is determined. So what does this whole of this means? Okay, so that means our organic compound, first it is made to react with concentrated sulfuric acid. We obtain ammonium sulfate. Ammonium sulfate is further made to react with excess of sodium hydroxide. Ammonia gas is liberated. Now ammonia gas is absorbed on a standard acid. Standard acid means the molarity is known, like any standard acid. Okay, once it is absorbed on a standard acid, that is actually the amount of ammonia which is liberated, right? So if we titrate this particular acid with an alkali, we can get exactly the amount of ammonia which is liberated, and from that we can calculate the amount of nitrogen which is also present. So what you have to understand is the amount of ammonia which is liberated is equal to the amount of H2SO4, whichever standard acid we have taken, it is equal to the consumption of that acid as well. Right? Okay. So now moving on to the calculation. The organic compound reacts with sulfuric acid, and first what did it form? Ammonium sulfate. Now the ammonium sulfate is reacting with sodium hydroxide in excess, and we get ammonia gas. Right, so this is what is happening. Now the ammonia gas is made to absorb on a standard acid. So here the standard acid taken is sulfuric acid, and then solution that you have obtained is then titrated with an alkali, and the volume of sulfuric acid is determined, which is equal to the amount of ammonia which is liberated, from which we can calculate the percentage of nitrogen. Right. So Gelder's method is not applicable for compounds containing nitrogen in the ring. For example, pyridine. In benzene ring, it is nitrogen which is present. That is called as pyridine. So if the nitrogen is present in ring, we can't use Gelder's method. Also, it can't be used for nitro groups as well as azo groups. Right. So this is also an important point. So now let us understand the procedure in detail. So first step is the conversion of nitrogen in the compound to ammonia sulfate. How do you convert it? We react it with sulfuric acid. Right. A sample of organic compound is weighed accurately and placed in Gelder's flask, and excess of concentrated sulfuric acid and potassium sulfate are added. Right, a little of mercuric sulfate is also added as catalyst, and the flask is heated until the solution becomes clear and then cooled. So this is the Gelder's flask, you can see. Okay, so our organic compound is taken here. We mix it with concentrated sulfuric acid and potassium sulfate. Okay, then we heat it. Okay, once we heat it, what is getting liberated here? Ammonium sulfate. Right, ammonium sulfate is liberated, and that is further cooled. Okay, so that is the first step. Now the next step is estimation of ammonia. The contents are transferred to a round bottom flask. Now once this step is done, we'll transfer this round bottom flask to another solution containing a strong solution of sodium hydroxide. Okay, then this organic compound, which is now containing ammonium sulfate, is now reacted with excess of sodium hydroxide. Now the apparatus is arranged and the flask is heated. Now again the flask is heated, that is ammonium sulfate plus the sodium hydroxide is heated, right, and the ammonia is liberated. Now ammonia will be liberated, which is passed through a condenser. The ammonia which is liberated is now passed through a condenser and absorbed in a non-volume of standard acid taken. Okay, ammonia liberated will pass through a condenser and it will be collected in the standard acid, which is molarity is known, right, and the unused acid is then titrated against the standard alkali. Now the acid which is containing the ammonia will be titrated with an alkali. Clear? So this is the procedure. Now let's move on to the calculation. Mass of organic compounds, if it is considered as W gram, and the volume of the standard acid required to neutralize this is calculated as V. Okay, so initially the mass is of the organic compound is W, and how much volume of acid is required is taken as V. Then the normality of the acid is taken as N. Normality is taken as N. Then V into N. Volume into normality of acid will be equal to volume into normality of ammonia. Okay, as I said, how much volume of acid is calculated, that will be exactly equal to the ammonia which is liberated. So V into N of acid will be V into N of ammonia. So 1000 centimeter cube of one normal ammonia contains 17 gram of ammonia. From where did I get the 17? Ammonia. So nitrogen is 14 plus hydrogen, 3 hydrogens are there, which will give me 17 gram of ammonia. Now 1000 centimeter cube in 1 liter, right, of one normal ammonia contains 14 gram of nitrogen. So in ammonia, how much nitrogen will be there? Yes, 14 gram. See, as you can see here, ammonia total it is 17 gram, and in ammonia, how much nitrogen is there? 14 gram. Right. So now V centimeter cube of N normal ammonia contains V into N by 1000 into 14 gram of nitrogen, which we are considering is as X. Okay. Now W gram of the organic compound contains X gram of nitrogen, and 100 gram, yes, if W gram of organic compound is containing X gram, then 100 gram of organic compound will contain W by X into 100, right? W by X into 100 gram of nitrogen. So hence, how do we calculate the percentage? So the final equation, percentage of nitrogen in the compound is volume of the acid. Okay, volume of the acid into normality of the acid into 14, right, divided by mass of organic compound into 100 by 1000. So this is the final equation to calculate the percentage, right? Now let's do a problem based on this as well. So 0.3465 gram of a compound on digestion with concentrated sulfuric acid and distillation with excess sodium hydroxide liberated ammonia which was absorbed in boric acid solution. So our standard acid here is boric acid solution. Okay, it required 42.80 centimeter cube decinormal hydrochloric acid for neutralization. Calculate the percentage of nitrogen. Okay, so let's see volume of the hydrochloric acid. How much volume was required? 42.8 centimeter cube, and the normality is also given, that is 0.1. Okay, and even the mass of the compound is also given, that is 0.3465. Okay, if we convert it into milligram, it becomes 346.5. Okay, now the percentage of nitrogen, what is the equation? V, volume into normality, volume of the acid into normality of the acid into 40 divided by mass of the organic compound into 100 by 1000. That is the equation, right? So what is the volume? 42.8. What is the normality? 0.1 into 14 divided by what is the mass? 346.5 in milligrams into 100 by 1000, which will give us 17.3%. So this is the example for a calculation based on Geldahl's method. So these are the two methods for the estimation of nitrogen. The first one was Dumas method and the second one is Geldahl's method. So that is about the estimation or quantitative analysis of nitrogen. Now moving on to the quantitative analysis of halogen, sulfur and phosphorus. Halogen, sulfur and phosphorus. So this is done using Carrier's method. So all these three can be determined using Carrier's method. A Carrier's tube will be used here, and based on the different reagents we use, we get the quantitative analysis of halogen, sulfur and phosphorus. So let's begin with the first one, that is quantitative analysis or estimation of halogens. Okay, yes. So to known amount of the organic compound, fuming nitric acid, what is nitric acid? HNO3. Fuming nitric acid and silver nitrate solution are added and strongly heated in Carrier's tube. So this is the Carrier's tube, as you can see here. The organic compound will be taken here and fuming nitric acid will be added along with silver nitrate. Okay, yes, so this is the first step. So what is happening here? The halogen present gets converted into corresponding silver halide and it is then further filtrated. Filtering is done and the silver halide that you are obtaining is then further washed and cooled, and then finally it is weighed. It is dried and then it is weighed. Okay, so this is the step that is happening. That is, the halogen containing organic compound is taken in the Carrier's tube. Fuming nitric acid and silver nitrate is added. What will be formed? The corresponding silver halide is formed. If you are taking chlorine, what will be the halide formed? Silver chloride. If you are taking bromine, the corresponding halide is silver bromide. And if we are taking iodine, the corresponding silver halide will be silver iodide. Okay, and this will be then undergone filtration. So the filtrate will be thrown out and whatever precipitate you are getting, that will be washed and then dried and then weighed, and from that we can calculate the percentage of halogens. Right, so now moving on to the calculations. Mass of the organic compound, it is taken as m gram. Hence, the mass of silver halide which is formed, it is taken as m1g. Mass of the whole of the organic compound is m. Mass of silver halide which is formed is taken as m1g. Okay, so if 1 mole of silver halide is formed, it contains 1 mole of halogen. Right, in 1 mole AgX, AgX means silver halide, right? It contains 1 mole of halogen. Okay, if it is 1 mole of silver chloride we have taken, it will be 1 mole of chlorine which is present there, right? Hence, the mass of halogen in m1 gram of silver halide is calculated as atomic weight of halogen into m1. What is m1? m1 is the mass of silver halide formed, divided by m weight. M weight means molecular weight of silver halide. So finally, how do we calculate the percentage of X? Percentage of X means percentage of halogen. So in the organic compound, how do we calculate the percentage of halogen? It is atomic weight of halogen into 100. This 100 is for the percentage, right? 100 into m1. m1 is the mass of silver halide formed, divided by molecular weight of silver halide into the mass of the organic compound. So this is the equation with which we can find the percentage of halogen. So let's do a problem based on this. In Carrier's method, 0.1190 gram of an organic compound have 0.2500 gram of silver chloride. So silver chloride is the silver halide which is formed. Okay, so our halogen is chlorine. Calculate the percentage of chlorine in the compound. So the mass of the organic compound is given. Right, mass of silver halide, that is silver chloride formed, is also given. Now the molecular mass of silver chloride we can calculate. For silver it is 108 atomic mass, and for chlorine it is 35.5. Okay, so the total will be 143.5. Yes, that is the molecular mass. Now if 143.5 of silver chloride is formed, it contains 35.5 gram of chlorine, right? Yes, that is clear. So then 0.2500 gram of silver chloride contains how much? Yes, that is 0.2500 into 35.5 divided by 143.5. So if this much gram of silver chloride is containing this much gram of chlorine, then this much of silver chloride contains, yes, 35.5 divided by this one, 143.5 into this value, right? So that is basic calculation. So we get the, in silver chloride, how much chlorine is there. So from that, how do we calculate the percentage of nitrogen? The same equation we can use, that is 0.2500. That is the same equation that we have studied. So this is M1, that is mass of the silver halide which is from silver chloride, right? And into atomic weight of the chlorine, right? Divided by 143.5, that is molecular weight of the silver halide which is formed, silver chloride, right? Into 100 divided by the overall mass of the organic compound, finally, which will give you 51.97%. So in the organic compound, 51.97% it consists of chlorine. So I hope it is clear. Now moving on to the next one, that is detection of sulfur. Okay, we are going to estimate sulfur, the amount of sulfur. So what do we do again? The method is called as Carrier's method. We will be conducting it in a Carrier's tube. So what we will be adding here, a known mass of organic compound is oxidized to sulfuric acid. Okay, it is sulfur is oxidized to sulfuric acid by heating it with fuming nitric acid or sodium peroxide in Carrier's tube. So in Carrier's tube, we will be taking fuming nitric acid or sodium peroxide. Okay. So what will happen? The sulfur will be converted into sulfuric acid. Now the acid formed is then treated with barium chloride solution. Now the acid which is formed, that is our sulfuric acid which is formed by the oxidation of sulfur, is then treated with barium chloride solution, and then you will be obtaining a precipitate of barium sulfate. So this is the reaction. Sulfur reacts with fuming nitric acid and it gives sulfuric acid. Now this sulfuric acid is made to react with barium chloride, which gives a white precipitate of barium sulfate. So from the precipitate, that is, what is the precipitate from? From barium sulfate. From the barium sulfate we can calculate the percentage of sulfur. Right? Okay. So now moving on to the calculation. The mass of organic compound is taken as M again, and the mass of barium sulfate which is formed. From barium sulfate we will be calculating the percentage of sulfur, right? So the mass of barium sulfate formed is considered as M1G. Okay. And 1 mole of barium sulfate is containing 233 gram of barium sulfate. 1 mole, that is the molar mass of barium sulfate, is 233 gram of barium sulfate. Okay, and 233 gram of barium sulfate contains 32 gram of sulfur. So in barium sulfate, how much is sulfur which is present? It is 32 gram, right? So 233 gram of barium sulfate contains 32 gram of sulfur. Then M1 gram of barium sulfate will contain how much? That is 32 divided by 233 into M1, right? 32 into M1 divided by 233. So that many amount of sulfur will be present in M1 gram of barium sulfate. Then how do we calculate the percentage? It is 32 into M1 divided by 233 into 100 divided by M. So what is this M1? It is the mass of barium sulfate which is formed, and M is the mass of the organic compound. Yes, I hope it is clear. Now again, let's do a problem based on this. 0.35 gram of organic compound on heating with fuming nitric acid and barium chloride gave 0.80 gram of barium sulfate, right? And calculate the mass and percentage of sulfur in the given compound. So, mass of organic compound is already given 0.35 gram. Mass of barium sulfate formed is also given. So, 233 gram of barium sulfate contains 32 gram of sulfur. So, from this, how much it is saying? 0.80 gram, right? It is given as 0.80 gram of barium sulfate. So, how do you calculate in 0.80 gram of barium sulfate? How much sulfur is there? That is what we have to calculate. So 32 into 0.80 divided by 233, that is 0.1098 gram of sulfur. So in this much gram of barium sulfate, this much gram will be sulfur. Then how do you calculate the percentage of sulfur? With the same equation, that is 0.1098, the mass of sulfur into 100 divided by 0.35, which will give you 31.37 percentage. Okay, so this is how you calculate the percentage of sulfur. Okay, so what is the reaction that is happening here? The organic compound is treated with the fuming nitric acid, and sulfuric acid is formed, which is further treated with barium chloride, and which gives barium sulfate as the precipitate, which is then weighed. Okay, so this is the calculation. Okay, so now moving on to the next one, that is phosphorus. So phosphorus is also estimated using Carius method. A known mass of the organic compound is oxidized to phosphoric acid. Here the phosphorus containing organic compound is converted into, that is oxidized. The phosphorus is oxidized to phosphoric acid using fuming nitric acid. Again we are taking fuming nitric acid, but phosphorus is getting oxidized to phosphoric acid. Right. Now the acid formed on treatment with ammonium and ammonium molybdate gives a yellow precipitate of ammonium phosphomolybdate. Okay, it is filtered, washed, dried and weighed, and from the weight of the precipitate formed we will be able to calculate the percentage of phosphorus. So what do? In the Carius tube we take the organic compound, we add in fuming nitric acid. What happens to the phosphorus? Phosphorus gets oxidized to phosphoric acid, and the acid formed, it is further treated with ammonia and ammonium molybdate. Okay, and what is the product which is formed? It gives a yellow product of ammonium phosphomolybdate. So that is having a yellow color. It is a precipitate, and that will be further washed, dried and weighed. From that we can calculate the percentage. Right. Okay. Now moving on to the calculation again. Mass of the organic compound is M, and the mass of ammonium phosphomolybdate which is formed is taken as M1 gram. Okay, so the molecular mass is also calculated as 1877 gram, 1877 gram. That is the molecular mass of ammonium phosphomolybdate. Now the atomic mass of phosphorus is 31 gram. So 1877 gram of ammonium phosphomolybdate contains 31 gram of phosphorus. Then M1 gram will contain how much? It will be M1 into 31 divided by 1877 gram. Okay, that means 1877 gram of ammonium phosphomolybdate is containing 31 gram of, yes, phosphorus. Then M1 gram will contain how much? 31 divided by 1877 into M1, right? So that is what is shown here. Then how do you calculate the percentage of phosphorus? It is M1 into 31 divided by 1877 into 100 by M. So this M is the mass of the organic compound, and this M1 is the amount of ammonium phosphomolybdate which is formed, right? So I hope it is clear. So this is one method by which we can calculate the percentage of phosphorus. Now another method is phosphorus can also be estimated by converting the phosphoric acid formed, right? That is the phosphorus containing organic compound. When it reacts with nitric acid, it forms phosphoric acid. Now this phosphoric acid, it is further reacted with magnesium pyrophosphate by heating it with magnesia mixture. Okay, and igniting the magnesium ammonium phosphate, precipitate is formed. From that as well, we can calculate the percentage of phosphorus. Then what change will be there in the final equation? Yes, now it is not ammonium phosphomolybdate, it is magnesium ammonium phosphate. So the molecular mass and the atomic mass will change, right? So the equation, that is the percentage of phosphorus, will be calculated using 62 into M1 by 222 into 100 by M1. So 62 is the atomic mass into M1. M1 is the amount of the magnesium ammonium phosphate which is formed, divided by the molecular mass of that into 100 by M is the total mass of the organic compound. So if it is converted into, that is the phosphoric acid is further converted into magnesium ammonium phosphate, we use this equation, and if it is converted into ammonium phosphomolybdate, we use this equation. So I hope it is clear, right? So now let's move on to the estimation of the last element, that is oxygen. So even this can be done with two methods. The first one, that is a general method which is used, is by taking the difference, that is the percentage of oxygen can be determined by taking the difference between the total percentage composition minus the sum of percentages of all other elements. So after calculating the percentages of all other elements, take the sum of it minus, that is subtract it from the total percentage composition, that is 100. So 100 minus the sum of percentages of all the elements, other elements, will give the percentage of oxygen. So this is the general method which is used, or separately we can calculate as well, which is what we are going to study now. That is, in this method, the given organic compound which is containing oxygen, right, is pyrolyzed. Pyrolyzed means what? Decomposed by heating. High temperature, under high temperature, it is decomposed. Okay, so that is called as pyrolyzing. In a stream of nitrogen, and the gases formed are passed through red hot coke, and carbon monoxide is formed. Right, okay, and carbon monoxide is formed. Now the carbon monoxide so formed is passed through warm iodine pentoxide to give carbon dioxide and iodine gas. Okay, right, so from that we can calculate the percentage of oxygen, that is the amount of carbon dioxide which is given out, right? So what is that we are doing? The organic compound is made, that is pyrolyzed by passing it through nitrogen, and the gases which are formed are passed through red hot coke now. Right, that is, it is reacted with carbon, and carbon monoxide is formed. Now the carbon monoxide which is formed is passed through warm iodine pentoxide, which will finally give carbon dioxide and iodine gas, from which the percentage can be calculated. So let us see. Okay, so the organic compound is first heated, right, pyrolyzed, that means under high temperature it is decomposed, and we obtain oxygen, right, and other gaseous products as well. Right, so now that is made to react with red hot coke, right? Red hot coke, that is carbon monoxide, will be formed. What will be formed? Carbon monoxide. Now this carbon monoxide is further reacted with iodine pentoxide, right? Iodine pentoxide, and we get carbon dioxide and iodine gas. Carbon dioxide and iodine gas is liberated. From the mass of carbon dioxide which is formed, we can calculate the percentage of oxygen. So now moving on to the calculations. What you have to remember is 1 mole of oxygen liberated. For every 1 mole of oxygen which is liberated, there is 2 mole of carbon dioxide which is formed. Okay, for 1 mole of oxygen which is liberated, 2 moles of carbon dioxide will be formed, right? So from the calculations, let's see, mass of organic compound is considered as m gram, and the mass of carbon dioxide form is calculated as m1 gram. So 44 gram of carbon dioxide contains 16 gram of oxygen. Now how this is calculated is 88 gram of carbon dioxide, that is 2 moles of carbon dioxide means 88 gram, right? 88 gram of carbon dioxide will contain 32 gram of oxygen, right? 32 gram of oxygen, right? Then how much will 44 gram of carbon dioxide contain? 44 gram of carbon dioxide will contain 16 gram of oxygen, right? So from this way, we can calculate this. 44 gram of carbon dioxide will contain 16 gram of oxygen. So that is 1 mole of oxygen which is liberated will give 2 moles of carbon dioxide. From that further, if we do the calculation, 44 gram of carbon dioxide will contain 16 gram of oxygen. So M1 gram of carbon dioxide, then how much will be there? For 16 into M1 divided by 44 gram. And the M gram of organic compound formed 16 into M1 by 44 gram of oxygen. Then for 100 gram, how much it will be? We multiply it by 100. So finally the percentage of oxygen, how we can calculate? 16 by 44 into M1, that is M1 is the mass of carbon dioxide which is formed, divided by M. M is the mass of the organic compound into 100. So now let's do a problem based on this as well. Calculate the percentage of oxygen present in 8 gram of an organic compound which gave 10.10 gram of carbon dioxide. When CO formed on heating, the organic compound with red hot coke is passed through iodine pentoxide. So the mass of organic compound is given as 8 gram. Mass of carbon dioxide is also given in the question, 10.10 gram. Now 44 gram of carbon dioxide will contain 16 gram of oxygen, right? 88 gram of carbon dioxide contain 32. So 44 gram contains 16, right? Now 10.10. If 44 is containing these many, 10.10 gram of carbon dioxide will contain 10.10 into 16 divided by 44. So finally, what is the equation to find out the percentage of oxygen? It is 10.10, right, into 16 divided by 44 into 100 by 8, which will give you 45.90 percentage. So this is how you calculate the percentage of oxygen. So that is how you calculate the percentage of oxygen in the organic compound. So I hope the different qualitative and quantitative methods are also clear for you. Yes, we discussed the qualitative methods, qualitative analysis first, and then we moved on to the quantitative analysis of different elements. In today's session, we studied for sulfur, halogens, phosphorus and nitrogen as well as oxygen, right? So I hope the different methods are clear for you. So by this we come to an end to this chapter. So I hope the whole chapter is clear for you. So we'll meet in the next session with a new chapter. So that's all for today. Thank you.